So we are in page 181 in your workbooks, and we're going to look at the sine law. So if you take a look, it starts by just reviewing our basic right triangle trigonometry. So we've got our three trig ratios, our basic trig ratios, which you guys often remember using SOHCAHTOA. So sine of theta being opposite over hypotenuse, and cosine of theta being adjacent over hypotenuse, tangent of theta being opposite over adjacent. And so since this is review for class example number 1, A and B, would you hit pause and just work through those examples then and come back and check your answers. So if we take a look at question A, we're trying to find the angle x. We know that we have the hypotenuse, which is 14. That's the longest length opposite the right angle. We also have the length that is opposite the missing angle x, and that length is 8. So since we're dealing with opposite and hypotenuse, we know that we can use a sine ratio to figure that out. So sine of x degrees is equal to 8 over 14. Because we're trying to find the angle, then we use the inverse sine of 8/14, and we can enter that right in as a fraction, and our calculator will let us know that we're talking about 35 degrees. For part B, we have the hypotenuse, which is x, and the length that is adjacent to our 40-degree angle, which is 19. So adjacent over hypotenuse is cosine. So we can set it up as cosine of 40 degrees is equal to adjacent over hypotenuse, or 19 over x. To isolate the x, we want to first multiply both sides by x, and so the x's in essence cancel each other out because that's x over 1. So I'm left with x cos 40 is equal to 19. To isolate x, we'll divide both sides by cosine 40 degrees. So x is 19 divided by cosine 40, and that tells us that the length of the hypotenuse is 25. So again, it gets a little bit more complicated when we have a triangle that is not a right triangle. So if we look at triangle ABC, that is not a right triangle. And so if we're trying to find the length of BC, what we end up having to do then is to draw in the altitude or the height of this triangle AD, and then doing using trig ratios to find BD, and then again to find length CD by finding the height AD, and that allows us to then add BD plus DC to find the length of BC. So again, if you want to try this on your own, then just hit pause and come back and take a look at the solution. Otherwise, I will work this one out with you guys then. So let's start off by finding length BD. I will label BD as X, DC or CD I'll label as Y, and the altitude or the height AD I'll label as H. So first off, to find X, X is important to us because that makes up part of length BC. So I know that I have the hypotenuse of triangle ABD. I also have the angle A, or angle BAD, that's opposite to X. So in triangle ABD, we know that sine of 20 degrees is equal to x over 12.5 centimeters. So then x is equal to 12.5 times the sine of 20 degrees. So that tells me that x is 4.275 centimeters, and x is also the length of BD. But in order to go into the other right triangle, triangle ADC, I don't have any lengths. However, I can find the height of triangle ABD, and that is also going to be the height of triangle ADC. Because I've got length x, I could use Pythagorean theorem. However, since x is a found value, ideally I want to use values that are already known, so I'll stick with that 20 degrees, the hypotenuse, h, or the height, becomes the adjacent, so then that will be cosine. So cosine of 20 degrees then is equal to h over 12.5. So h will equal 12.5 times the cosine of 20 degrees. And so that says that h, or the height, is 11.746 centimeters. That's approximate, so that is again about a D is our height there. So now that we have these, and I'll just put a little box around them so I know that these are some important values for me to use. Okay. So then we'll move into triangle ADC so I can find length Y. So in triangle ACD, we'll call it, then I have the height. If I want y, I can now have a choice. I can either use the 55 degrees or I can use the 35 degrees. It doesn't actually matter because we'll be using tangent ratio, which is opposite over adjacent. So I'm just going to use tangent of 55 degrees, and opposite 55 degrees is our y, so oftentimes the variable is just a little bit easier to solve for when it's in the numerator, so it's y over h, and h is 11.746. And so then y will be approximately 11.746 multiplied by the tan of 55 degrees, and we can put that right into our calculators. And so y is approximately 16.775 centimeters, and y is of course the length of CD. So again, that is one of the lengths that we're looking for there. And so in order for us to find BC, BC is obviously going to be BD plus CD, so that is 4.275 plus 16.775, which then is approximately 12.05 centimeters. So they've given us to work to 3 decimal places. These are all approximations, and then rounding our answer to 2 decimal places. So this is our final answer for length BC. So that is quite a process in order to find the length of BC. We had to do 4 steps in order to get there. They weren't very difficult, but it is still a long process. So obviously we're thinking to ourselves, wouldn't it be great if there was an easier way? And lo and behold, of course there is, and in comes the sine law. So let's take a look then. Just as with our right triangles, if we have a particular triangle ABC, recognizing that when we name the lengths, I could name this length AC, but we're going to give it the name of lowercase of whatever is opposite it. So angle B is opposite length B. Angle A is opposite length A, and angle C is opposite length C. So we'll use the lowercase letters to indicate lengths, uppercase letters or capital letters to indicate angles. So the sine law is in every triangle ABC, we can put the lengths, the ratio of the length to the sine ratio is equal to all of those other lengths to their corresponding ratios. Or inversely, you can flip all of them, because it's no different than me saying 1 over 2 is equal to 2 over 4 is equal to 3 over 6, as 2 over 1 is the same as 4 over 2 is the same as 6 over 3. So they are exactly the same, so as long as we're consistent all the way through. So why is that? So let's run through the proof then. So the proof of the sine law is if we are to take that same triangle, triangle ABC, we recognize that if we go back to the idea of having that height or that altitude in there that we're going to use to find it. So sine A is going to be opposite, so length CD, or that length A, over AC, or that hypotenuse. So we have sine A is equal to CD, which is our height, or length A, over B. So to find CD, then we know that it is going to be equal to B sine A. Okay. Similarly, if we take a look at sine B is going to equal CD over BC, and CD over A. So similarly, we can say that sine B is CD over A, or CD is equal to A sine B. So since CD equals B sine A, CD also equals A sine B, then B sine A must equal A sine B. If we divide both sides by sine A sine B, then that's where we end up with our sine law. Okay, so similarly, they've used the letters if we said that this is height. So essentially what are we doing is we're saying height is one thing, height is another thing, so that means that they must be equal to the same thing then. Okay? So let's take a look at how we can apply that. So if we go back to that same triangle that we had previously, so what do we know? We have A, we're angle A, we're looking for length A, which is length BC, and we have angle C, and we have length C. So what are we looking for in essence is we're looking for these opposites. So A and A, and C and C. And so when we have that, when we see those opposites, we can use sine law. So we can say that A over sine A is equal to C over sine C. So then A over sine 75 degrees is equal to 12.5 over sine of 35 degrees. And if we multiply both sides by sine 75 in order to isolate A, then A is equal to 12.5 times the sine of 75 degrees, all divided by the sine of 35 degrees, and you can put that all right into your calculator, and right away it tells us that A, which is also the length of BC, is equal to 21.05 centimeters, which is what we had on the previous question. So let's take a look at class example number 4. So in class example number 4, we are trying to determine the measure. Whoops, that jumped a bit. We're trying to determine the measure of angle ACB. So if we look at ACB, then we're talking actually about angle C to the nearest degree. So what do we have is that we have this pair, which is really nice. The issue with C is we don't actually have that opposite length. We do, however, have length B, and this is opposite angle B. So what do we know is, well, if I figure out angle B, then I know angle A, and since all angles in a triangle add up to 180 degrees, then I can use angle B then to work my way over to figuring out angle C. So this is going to be the pair that I'm going to be looking at. So we have sine B over B is equal to sine A over A, And so why did I actually reverse that around from last time I used A over sine A is equal to B over sine B? Because oftentimes it's easier to solve when the variable is in the numerator, and since it doesn't actually matter how you arrange it, then we'll put the variable or unknown in the numerator. So then we fill in what we have. So sine of B is over 6, and that is equal to the sine of 110 degrees over 9.4. We'll multiply both sides by 6, so then sine of B is equal to 6 sine of 110 degrees divided by 9.4. And then we're going to take the inverse sine. So if you want to, you can enter 6 sine 110 degrees divided by 9.4, and what we should end up with is an approximation. So sine of B is approximately 0.5998, and it goes on for a few decimal places. Leave all of those decimal places, and then now let's do the inverse sine of all of those decimal places. So angle B is going to be equal to the inverse sine of all of those decimal places. So with your calculator, you can just put in that answer button, use that keystroke, and that tells us then that angle B is approximately 37 degrees. So since angle A is equal to 100 degrees, so we know that angle A plus angle B plus angle C obviously has to equal 180 degrees. So A is 110 degrees plus 37 degrees plus angle C has to equal 180 degrees. So then angle C has to be 180 minus 147 degrees. So angle C then is 33 degrees. Awesome. Okay, moving on to class example number 5. So a survey measures a baseline PQ that is 440 meters long. So we can see that they've drawn in that triangle for us. So we'll just label in that length. So PQ is 440 meters. Takes measurements of a landmark R from P and Q and finds that angle QPR, so QPR, so that is 46 degrees, and PQR is 75 degrees, and we're looking for the perimeter. So at this point, I actually don't have any pairs, but because I know 2 angles, I automatically know 3 angles, because again, the angles have to add up to 180 degrees. So in order to find angle R, I know that it's going to be 180 degrees minus 46 degrees and minus 75 degrees. So angle R is going to be 59 degrees. So at that point, I can write that in so that I can see that. And right now we can see that we have this pair of R and R, angle R and length R, and so then we can use that known pair to solve for my other 2 missing lengths in order to find the perimeter. So now that we have our known pair of angle R and length R, we can set up our ratios. So since our missing values are our lengths, then we're going to use the version with the lengths being on top. So for P, we can say length P over sine of angle P is equal to length R over sine of angle R. Or filling in what we know, P over sine of 46 degrees is equal to 440 over sine of 59 degrees. When we want to isolate length P, we multiply both sides by sine of 46. So then P is equal to 440 times sine of 46 degrees, all divided by sine of 59 degrees. And then that gives us the fact that length P is equal to 369.25 5 meters. So even though it says that our answer for the perimeter needs to be rounded to the nearest meter, we want to keep a couple of decimal places so that our rounding doesn't actually affect that final answer. So let's take a look at finding length Q. So again, we'll have Q over sine of Q is equal to R over sine of R. And so Q over sine of 75 degrees is equal to 440 over sine of 59 degrees. And the question is often, well, can I use the length and corresponding angles for P? Because R is the given value, P is a found value, it's also a rounded value. We'd like to use something that is exact as possible and something that we also know is correct. Because obviously if P is wrong, then our answer for Q is also instantly wrong. So if we multiply both sides by sine of 75 degrees, that allows us to isolate for Q. So Q is then 440 times sine of 75 degrees, all divided by sine of 59 degrees, and we can enter that all into our calculator at once. And so length Q comes out to 495.83 meters. The perimeter then is, of course, the sum of all three lengths. So perimeter is going to equal 440 plus 369.25 plus 495.83, and when we round to the nearest whole, we end up with a perimeter of 1,305 meters. Excellent. So we can see that for part B on the next page, it asks us to calculate the area of triangle PQR to the nearest 100 square meters. So we know for area of a triangle, we need base times height divided by 2, of course. So if I sketch the triangle here again, then we've got P, R, and Q, and we know that this is 440 meters, so that is the length of our base. Again, we want to use a given value as opposed to a found value, because theoretically we could have length Q or length P being the base and then finding the height, but because we've already been given 440 meters, that's the exact value. Let's go with that. So then the height, if we draw a line straight down from R, we end up with that altitude or that height. Because we don't know that, well, we do know that this is not isosceles because we don't have two angles the same. We can't assume that this is 220 and 220, nor that these two, that 59 degrees has been split up equally. But what do we know is that this angle is 46 degrees, and let's go with one of the found values. So we can go with the fact that we have 46 degrees and that we have length Q, which is 495.83. And so at this point we can use the sine trig ratio for right triangles, and we can say then that sine 46 degrees is equal to the opposite, which is h, over the hypotenuse, which is 495.83. And so again, to isolate h, we need to multiply both sides by 495.83. So h will equal 495.83 times the sine of 46 degrees. If we enter that into our calculators, that will give us approximately 356.67. So then area is equal to base times height divided by 2, or we can also say 1/2 base times height, or 1/2 the base length is 440 meters, the height is 356.67, and when we put that into our calculator, we end up with an approximate area of 78,500, so rounded to the nearest 100 square meters then. So again, could you have used angle Q and the length P of 369.25? That would of course work as well. Okay, so that is sine law, and it's time to do some practice. Let me know if you have questions.